Okay, so here we've got some copper sulfate, and we've got 14.37 grams of hydrated copper sulfate. And we're also told that the anhydrous sample has a mass of 8.97 grams, and we need to find out the value of X, right? And effectively what the value of X, as far as the meaning, is simply for every 1 mole of CuSO₄, how many moles of H2O do we have, right? So this is roughly what the value of X tells us. And using that information, it kind of helps to guide how we're going to really work out this question. So initially, I'm going to look into figuring out the relative number of moles of each as it stands based on the masses we've been given. Now for the copper sulfate, the actual mass of the copper sulfate would be indicated by the anhydrous sample mass, which is 8.97 grams. To get to the actual moles from that, though, we need to use the equation that the number of moles N is equal to the mass divided by mR, the molar mass, right? So in this case, the number of moles of CuSO₄ is going to be equal to 8.97 divided by the molar mass. Now we don't have the molar mass right here, but we do have the fact that the formula is CuSO₄, right? Now given the formula is CuSO₄, we can use that to work out the molar mass, right? So that would be, so for copper, we've got like a few excerpts from the periodic table here. So you've got copper, sulfur, and of course oxygen. So it's here as well for simplicity, but for this it would be, we could say the mR, so molar mass of CuSO₄, is equal to, and then 63.5 for the copper, for the sulfur 32.1, and for the O4 aspect would be effectively 4 times 16, right? And so that would effectively give us a value of 159.6, okay? And this would be in units of grams per mole. Now we can use this value, so 159.6, that would be the value here for the molar mass, and from that we can work out the number of moles. So if you do have a go at working out what the actual number of moles is here, you should find that you get 0.056 okay, and that's going to be in moles, and this is just simply the value to 5 significant figures. Now for H2O, we have 2 masses here, right? So this is the hydrated, this is the anhydrous, and these are both for the copper sulfate. What we can effectively deduce is that, well, if we do some arithmetic here, if we subtract 8.97 from 14.37, what's remaining is going to be the mass of the H2O effectively, right? So mass of H2O is going to be equal to 14.37 minus 8.97, right? So if you do have a go at working that out, you should find that you get 5.4. Now that mass is effectively going to enable us to work out the number of moles of the H2O. Okay, so we're going to need the molar mass as well, right? So the number of moles is equal to the mass 5.4 So this, just for clarity, that is the number of moles of H2O, right? So number of moles of H2O is going to be equal to 5.4. Let me just put that there. So that was grams anyway. So divided by the molar mass of H2O. Now, you may know what that is, but let's just go through the process. So hydrogen, oxygen, we've got this here. It's going to be H2, so that's going to be 1 times 2 plus the O aspect, right? So M of H2O, let's just put that there. It's equal to plus 16, which is going to be 18, of course, 18 grams per mole, right? And so I'm now going to use that value of the molar mass here. That's going to give us the number of moles of H2O. So if you work that out, you should find that this comes to 0.3. Okay, that's going to be in moles. Okay, so we actually have a molar value now of the CuSO4 and of the H2O, right? So for CuSO4 x H2O, you've got values for both. But you notice here that the coefficient here is 1, right, effectively. But here, we've got, obviously this is not 1, so there's still more work to do to actually make meaning out of this these ratios. So what we can say, and I'm going to put the CuSO4 on the left hand side because it is on the left hand side here. The number of moles of CuSO4 compared to the number of moles of H2O. We've got 0.056203 in a ratio with 0.3, right? And what we can effectively say is we want this to be scaled up to 1, right? Because we want to be able to compare it as part of this. So what we can do to get it to 1 is divide it by itself, right? So I'm going to do that. So it's going to be divided by 0.056203. This is going to, because we've done it to this side, we also do need to divide this side by the same because it is a ratio, right? So 0.056203. Now, because we're dividing this by itself, of course, this side is going to give us 1, right? But I'd invite you to have a go on your calculator to work out what the right hand side is going to give us. If you do that, you should find you get 5.3378. Okay. And well, at this stage, we have 1 on the left hand side, which is what we were really aiming at. We wanted to have 1 on the left hand side. As far as the right hand side goes, we do need an integer value. So what we're going to do is we're actually going to round it to the closest integer value, which in this particular case is going to be 5. Okay, so we're going to round that to 5. And so we're going to say that this is 1, this ratio of basically approximately 5, right? And so therefore we can say that the x, it's a bit of a wonky x, isn't it? So let's just make this a bit more. Therefore x is equal to 5, right? And if x is equal to 5, then we can say really it's going to be CuSO4 dot 5 H2O, right? And similarly over here, it said, fill in that space with the value. So we're going to just put 5 in there, right? So yeah, that would be how you would, go about figuring out the value of x in this case.